Now in this video we look at question number 5. Question number 5 says we have a Carnot engine CE1 which is working between 900 Kelvin and 500 Kelvin. Okay. A second Carnot engine, we have two engines over here, CE2, so we are naming it CE2, which works between 500 Kelvin and 300 Kelvin. So the heat sink for one, as per the statement, the heat sink for CE1 becomes the heat source for CE2. Okay, all the heat which is rejected by CE1 is taken by CE2. Okay, if QA is 150 megajoules, which is taken up by CE1 at 900 Kelvin, the net heat rejected to reservoir C by CE2 is how much? Okay, so let's draw a diagram out of it first of all. So you have the highest temperature as 900 Kelvin. So this is reservoir A at TA of 900 Kelvin. Okay, this provides heat to CE1 and it rejects heat to reservoir B at 500 Kelvin. Right. So this QA is 150 megajoules and then this is QB. Right. So whatever heat this rejects taken up by CE2, so this is CE2, so this is QB. Okay, and then you have the last sink as TC, which is at 300 Kelvin. So we need to find out the heat rejected to reservoir C by CE2. So we need to find out QC. So we also don't know QB. Okay, let us say this is W1 and this is W2. Now W1 is how much? QA minus QB, and this is equal to QB minus QC. Okay, now because it's the Carnot engine, so the efficiency of the first Carnot engine, this is equal to 1 minus TB upon TA. Okay, so this would be equal to 1 minus 500 by 900. So eta 1 would be 0.445. So 44.5% would be the efficiency of the first Carnot engine. Now, this is also equal to the work output by the heat input. Okay, because we need to find out QB first. So W1 is equal to QA minus QB by QA. So this would be equal to 1 minus QB upon QA. Okay, so this is eta 1. So this will be QB upon QA is equal to 1 minus eta 1. You can take QA up there, so you will have QB is equal to 1 minus eta 1 into QA. Right, so this would be 1 minus 0.445 into QA, which is 150. So this would be around 53.33 megajoules. So this is the amount of heat rejected by CE1 to B, and I will write this down as this. So by following the same procedure, I need to find out QC. Okay, so for that I will find out eta 2, which is 1 minus TC by TB, which is 1 minus 300 by 500, which will give you exactly 40% efficiency. So you'll have QC as 1 minus eta 2 into QB. So just put in the values into, so this would be 50 megajoules. So the amount of heat rejected to C is 50 megajoules. So I hope you understood this entire flow, which is a very simple question on cyclic heat engines using the concept of Carnot heat engine. So this was question number 5 for you. I hope you understood it. Now let's move on to question number 6 in the next video.